All right, welcome back. Have you ever thought about this? You take a super smart AI, you teach it something new, and somehow it gets dumber? It's bizarre, right? It learns one thing, but then completely blanks on something it used to know. Well, today we're going to put on our detective hats and crack the case of this forgetful genius.
Okay, so check out this comic from the actual research paper. It just sets up the mystery perfectly. You've got the AI in a math class, right? And it's learning that a soccer ball is technically a truncated icosahedron. Super specific. But then fast forward to the soccer field and it can't even remember the word ball. This right here is the exact problem we're digging into. It's this wild idea that new knowledge can just wipe out the old stuff. And there's actually a name for this. It's called catastrophic forgetting. And trust me, it's a massive headache for anyone developing AI. I mean, can you imagine? You spend months, maybe even millions of dollars training this incredibly powerful model on all sorts of general knowledge, and then the moment you try to teach it something specific, like medicine or how to code, it all starts to fall apart. It's super frustrating and, yeah, really expensive.
So where do we start our investigation? Well, we're going to look at the two main ways we actually teach an AI. Let's think of them as our two main suspects in this case. One of them seems to have a pretty solid alibi, but the other one, yeah, that one's always hanging around the scene of the crime.
All right, so meet our suspects. On one side, you've got Supervised Fine-Tuning, or SFT. The best way to think about SFT is like a really strict teacher with a huge stack of flashcards. It's just forcing the model to memorize one specific right answer over and over again. Then on the other side, we have Reinforcement Learning, or RL. This one's way more chill, kind of like learning by doing. The model tries stuff out, makes its own answers, and then gets feedback on how it did.
And this is where things get really interesting. This is the central question of our whole investigation. All the evidence points to reinforcement learning being pretty good at keeping the AI's general knowledge safe. But SFT, our strict teacher, that's the one that seems to be causing all the memory loss. So what is it about SFT that's so destructive? What's going on here?
So to figure this out, the researchers did exactly what a good detective would do. They went straight to the evidence. They dug deep, and I mean deep, into the data. They looked at every single piece of information the AI was learning, literally every single token, searching for a pattern, for the smoking gun.
And boom, here it is. This is the evidence, plain as day. Look on the right, that's the data from our innocent suspect, reinforcement learning. It's all spread out pretty clean. But then look to the left. That's our prime suspect, SFT. See that massive, dense red blob in the bottom corner? That's it. That is our smoking gun. The whole problem is sitting right there in that cluster.
So what is that red cluster? The researchers give it a name, confident conflicts. And it's exactly what it sounds like. These are the moments where the AI is super sure it knows the right answer. It's very confident. But the new training data comes in and says, nope, you're wrong. The answer is this. It's basically a full-on brawl between what the model already knows and the new stuff it's being forced to swallow.
You can kind of boil the whole problem down to a simple formula. You've got a really confident, let's just say stubborn AI, and then you feed it a new fact that is totally surprising to it. What happens? The whole learning process just goes completely haywire. The AI pushes so hard to learn this one new, surprising thing that it ends up just breaking everything else it already knew.
And check this out. This is the final nail in the coffin. The researchers ran a test where they just told the AI to ignore these confident conflicts. They just masked them during training. And look at the result. The blue line shows what happened. The forgetting basically stopped. Compare that to the red line, which is normal SFT. It's a night and day difference. This proves it. These conflicts are the bad guy. Case closed.
Okay, but solving the crime is only half the battle, right? We found the culprit. Now, how do we stop it? Well, this is the cool part. The researchers came up with this incredibly clever solution to teach the AI in a much smarter way.
They call it Entropy-Adaptive Fine-Tuning, or, EAFT for short. Now, I know, the name sounds super technical and complicated, but the actual idea behind it, it's beautifully simple, really elegant.
So here's the game plan for how EAFT works. Step 1, it just checks how uncertain the AI is about something. That's the entropy part. Now, if the AI is genuinely uncertain, cool, it learns normally, just like it would have before. But, and this is the absolute key, if the AI is super confident, but it's wrong, instead of forcing this big destructive update, EAFT just tells it to learn gently. It's like giving it a little nudge instead of shouting in its face.
This image just shows the difference perfectly. Look at the left.
That's SFT, our old method. See all that dark purple? That's SFT applying huge aggressive pressure on those conflicts we talked about. But now look at the right. That's EAFT. That same exact area is now a pale yellow. The learning pressure is practically zero. It's smart enough to know when to back off and just ignore the conflicts that would cause all the damage.
There's a quote from the paper that just nails it. It says, EAFT leverages entropy to distinguish rigidity from uncertainty. In other words, it uses the AI's own confusion level as a signal. It can tell the difference between when the AI is just being stubborn and wrong versus when it's genuinely uncertain and needs to learn. It's not just a teacher, it's a smarter, more adaptive teacher.
So, okay, the theory sounds great. The idea is brilliant, but did it actually work in practice? Let's get to the verdict. The researchers went all out. They ran a ton of experiments on different AI models across all sorts of specialized areas like math and medicine to see if EAFT was the real deal.
And the results? Honestly, they're fantastic. So in this chart, any bar going up means the AI got better at the new skill. Any bar going down shows how much general knowledge it forgot in the process. Look at SFT in red. Sure, it learns the new skill, but look at that massive drop. It forgets so much. Now look at EAFT in blue. It gets pretty much the same boosts on the new skill, but with way less forgetting. It's a huge win.
Let's just pull out one number here to really see the impact. They tested this on a massive 32 billion parameter model. The old way, SFT, caused a 3.2-point drop in general knowledge. That's a big hit. But with EAFT, that damage was slashed to just a 1.1-point drop. I mean, that's a massive improvement. It's keeping the model's core knowledge so much safer.
And this final chart, this really tells the whole story. Okay, so the goal here is to be in the top right corner. That's the sweet spot. It means you're great at the new skill and you're holding on to your general knowledge. Now you can see standard SFT way over there, not even close, suffering from that huge forgetting problem. But look where all the EAFT methods are. They're all clustered right there in that perfect optimal zone. It really is the best of both worlds.
So what's the big takeaway here? Why does this matter so much? Well, it means we can finally teach AI models new, specialized skills without being terrified that we're going to break them. It makes the whole process safer and way more efficient. We don't have to deal with the insane cost and time of retraining these giant models from scratch every single time. This really paves the way for AI that is more capable, more reliable, and can just keep learning, as it should.
So there you have it. We've solved the mystery of the forgetful genius. And it turns out the problem wasn't the AI at all, it was how we were trying to teach it. We found a smarter, gentler way to pass on knowledge. And that just leaves us with one big, exciting question. Now that we can actually teach an AI without making it forget, what's the first thing we should teach it?